The paper-producing industry faces great challenges in meeting quality demands and efficient production without unexpected downtime. The production of paper is very complex. At temperatures of up to 115 degrees Celsius and a humidity of up to 100%, paper is produced in plants that are several hundred meters long and consist of several hundred rolling bearings, drives and drive rollers. Each of these components can lead to a breakdown and must therefore be regularly maintained. The aim of the project Retrofit4PAPER is to automate the maintenance process and to enable predictive maintenance. For this purpose, wireless sensor units, which supply energy from the machine heat and send sensor data to a central computer if required, are retrofitted. The combination of retrofitable, energy-autonomous sensor platform and AI makes it possible to make production processes in the industry smart, efficient and reliable. In the Retrofit4PAPER project, a retrofitable and wireless IoT sensor platform with extremely low power consumption in combination with embedded AI algorithms for predictive maintenance was implemented using the example of rolling bearings in paper production at ambient temperatures up to 115 degrees Celsius. With the continuous data analysis of the sensor information and trend changes, it is, for the first time, possible to recognize the condition of rolling bearings that are difficult or impossible to access over a longer period of time. For the project partner camera, this results in savings in the areas of avoided breakdowns of the paper machines as well as utilization of the service life of the bearing units and better planning of maintenance activities. The components to be monitored, such as bearings and drives, are also found in other manufacturing industries, such as the pharmaceutical and food industries.